Assalamu alaikum everyone. Let's start the lecture. In last lecture we studied about the concept of slope, where we came to know that slope is kind of variation in a certain change distance, or you can say that once we are approaching to some target point or we are covering some distance but with some limit, some restrictions, then the concept of slope, or you can say that the normal equation of slope is transformed into the tangent equation of slope. So for this we also need to see the concept of limit. There is an example in which I would like to emphasize the concept of limit, that how we can limitize or shrink the system in order to target the desired output. For example, in this case, remember, if this x in denominator is equivalent to 0, then equal to 0, then system will not work. Any function or any, for example, machine, there is no electricity. Okay, this in the denominator case is just kind of a generalization case. If there is no electricity, then fan will not work, no light will turn on, even though you have a machine, but without electric supply it will not work. Similarly, if it is equal to 0, then system will not work, or you can say that limit or your desired output will not be generated, thus you can say limit does not exist. And this is kind of a signal. You can say that the value of x, and here the in terms of radian. Okay, usually we see that in the radians are measured in 180 degree instead of the pi. So let's calculate this function, but before proceeding to calculate the limit, I would like to tell you that it is not a one-way process. It is the two-way process, that you need to focus the target point, and you need to cover up, or you need to come around the target point from various directions. But for simplicity, we are considering the two direction, that is on a real line. For example, this is the center point 0, and there are certain values. You can say these are the -1, -2, -3. Similarly, if we are observing the positive axis side, you can say that +1, +2, and +3. Okay, this is our main target point. We want to reach there. We want to reach at this point. So this is your left hand side, and this is your right hand side. So you want to travel some distance toward this. Oh, it may be possible you are standing here, and you, of course, you need to move toward the center. This is the center point. So the concept of limit is look like this, that once the x is on a left hand side on a real line, definitely it is approaching from negative side to 0. The other way, x is approaching towards 0 from the positive side. So in both the cases, we have a function, and this function will be transformed to your desired output. So by substituting the values, for a moment we can consider this example, and by substituting the various value on a random basis, these are not the fixed value, but for checking our system, machine is observing that this system is work in an amicable way or not in an amicable way. So by substituting the random value in a negative side as well as in the positive side, and this one is the negative side, as well as in the positive side. So we need to consider the two values of x. One is the negative, the other one are the positive. So our f of x is this one. For negative x, if we have 1, negative 1, by substituting the value of negative 1 here, we will, let me write out the answer of this instead of writing the exact value. I already calculated it. So when we are substituting negative 1 here, we will get an answer 0.84147. This is attained by substituting the value of x here as well as here. But this x value is negative 1. Similarly, by considering the value of x in a negative formation, but a little bit random step, you can see the interval of the 0.2. Now substituting 0.2 here in the numerator and denominator, we will get 0.89670. Similarly, for 0.6 we will get 0.94107. For 0.4 we will get 0.97355. For 0.2 we will get 0.99335. So similarly, for value of a 0.01 we will get a very almost near to 1, 0.9998. By considering the value of x in positive, for positive case 1, 0.8, similarly 0.6, 0.4, 0.2, 0.01. The output you can check it on your calculator and verify it. Okay, you will, once you substitute the value of x as a positive 1, then you will get 0.84147. Similarly, for 0.8 you will get 0.89670. For 0.6 you will get 0.94107. For 0.4 you will get 0.97355. For 0.2 you will get 99335. For 0.01 you will get 9998. Dear student, it's pretty clear that left hand side values and right hand side values are almost equivalent to almost equivalent for the same. For for positive 1 0.84147, for negative 1 we are getting 0.84147. For negative 0.01 we are getting 0.9998. For positive 0.01 we are getting 0.998. both are exactly same. So what happened? Technically, left hand side limit equivalent to the right hand side limit. This concept shows that we can say that limit exists. Once the limit exists, then our system will work amicably. So we can say that limit 1 equivalent to the limit 2, or we can, in a simplified form, we can say that function is following the limit, or it is some controlling criteria, and limit does exist. Yes, please. No, hopefully it will work. So limit is existing in this case. Once the limit exists, then we can say our system is in a working condition. This is the concept of limit. But remember this x approaches to 0 does not mean that x exactly equivalent to 0. It does not mean that x exactly equivalent to, it approaches to 0, nearly, maybe x 0.001 are almost similar like this, but as I am telling you that left hand side and the right hand side limit once equivalent, maybe it is not exactly equivalent to 0, then again we can say that limit exists, and whatever the value here we can get our answer. So this is the case of a limit. As I already told you, the concept of limit is that we can understand what is the working output